The next talk today is getting started with Easy. Hand over to Thomas to talk about this.
Thanks, Simon. Okay, so my name is Thomas Lopez. I work at the University of Bergen in Norway, and I'm for a while involved with Easy. And today I would like to talk about getting started with Easy. So first, the outline for the talk is roughly I first talk a little bit about what is Easy, what is the motivation for this talk, also a bit background of how is Easy structured, how we build software, and then I will show you in a couple of scenarios how you can get Easy to use. Okay, so first, what is Easy? Let's say the challenge is that you want to have the same software everywhere on an HPC system, cloud, servers, or laptops. And you want to have the software use optimized for specific CPUs. You want to have it well tested, and it will also work on different operating systems. And of course, you also want not spend a lot of time setting it up. So best would be if it's plug and play. And the solution there, of course, is Easy, the European Environment for Scientific Software Installation. You could think of Easy as it streams scientific software installations on demand. You can use it on any machine, anywhere, and you get the software nearly instantly available. Sometimes on the slides there are a few URLs with more information. For example, there the web page, central landing page for the Easy project, and also documentation on GitHub. Okay, so a little bit motivation about this talk, a bit about the history of Easy and the future. Development of Easy has started in early 2020, so 2 years ago. And the first prototype we had already maybe after 6 months or so, mid of 2020. And then you could ask, okay, why does it take so long to develop this? And of course, we did a lot of testing. We need to build up competence. Was important to build a community also. We did some tutorials, also some talks, wrote a paper, applied for funding, and of course, in all this time, there was a lot of improvement internally. The hope is that sometime this year we can say, okay, now we have the first version of Easy ready, so that we can also go for real deployment, and then maybe early 2 years, so maybe at the second next EasyBuild user meeting, we have it in production. Of course, it doesn't mean that the development would end this year. There will be more features requested, more internal improvements, and so on. So the development will go on, and then we will have new releases for Easy and also then deploy it and use it. With background on why Norway is interested in this. So at the moment, we have just started a project for to procure our next HPC system. And so the design of this should be known sometime early next year. And then it should go into production 2024. And we hope that we can use Easy as the main or default software stack on this system. Okay, so for whom is this talk? And maybe for whom it is not. So it is for anyone who wants to try out Easy and also try it anywhere. It is also for system administrators who want to make Easy available on their systems. And it is also for developers, for example, of scientific codes who want to build on top of Easy. And just in the middle here, so any attempt to use Easy and to provide feedback is highly encouraged. Why we want to do this or are interested in this, of course, is the earlier we get feedback, for example, something is not working, would help us to improve data, fix bugs, and so on. And then hopefully the deployment phase is going better, and also production is more stable. So in this talk, I will not cover many details of EaSI, of the internals, how do we develop EaSI, or how we extend it, or you can extend it. It's more how to really use it. A disclaimer there, we always say the EaSI pilot, which I will show, is not ready for production. Yeah, you can try it, but you cannot use it for production yet. Okay, so here's a high-level overview of the EaSI project. So there all the colored layers are components of EaSI, and the gray layer is what we get basically from the operating system. How we at the lowest layer, next layer is the file system layer that we use to distribute software stacks, and here we use CERN-VMFS. Next comes the compatibility layer, and that we use to have one interface to different client operating systems. So at the software layer, we don't need to deal with different operating systems. Here we use Gentoo prefix. And then at the top layer, of course, we have the software layer with optimized applications, libraries, dependencies, tool chains, and so on. And there we use very well-known tools, Elmod and EasyBuild, and we use a small library which helps us detecting what kind of CPU we have on the system. On the left side, you see a reframe named here. This is a reframe we want to use for testing. Okay, so a little bit more detail on the distribution infrastructure. As said, we use CERN-VMFS. In the middle, you see the central server where all the software stacks are stored. And that's the only server where you can add software. All the other servers and components are read-only. Then at the circle, you see sort of mirrors for this central server. They provide more performance because they are probably closer to where your system is, and also redundancy. And then what you also see on the left side, the user can have access to the software on their own system, on the cloud system, on the HPC cluster. And they can access one of these mirrors directly, or also via cache, a proxy. Okay, so maybe also a little bit about how we build a software stack. Okay, so the first thing is we have to build a compatibility layer, and we do this for CPU family, for example, x86 or ARM, and we also support at the moment Power. And then we ingest that into the repository on the CERN-VMFS central server. And then the next step is that we build application software stacks for each target CPU architecture we want to support. For example, Intel Skylake, AMD Rome, and so on. We build one specific stack so that we can optimize that then for this architecture. And then, of course, we also ingest that into the repository on the central CERN-VMFS server. If you would like to compare this, so that's not really an let's say scientific comparison here. If you compare this with traditional building software stack with EasyBuild, that would be just step 2 on a shared file system. And when we do this, so when we do build with EasyBuild the software stack, then in the step 2, then we also ensure that the compatibility layer is used, and that is distributed via certain VMFS. You could also, of course, compare this to containers if you want them. Then you could say that the step one, where we build the compatibility layer, provides some kind of container-like abstraction for software in EaSI. Okay, so that's basically all I want to say about EaSI, to give you a bit background. So now I have 4 scenarios I would like to introduce to show. The first scenario is that EaSI is available on your system. Yeah, so via certain VMFS, the first step could be that you just check this. So you would check if this directory is available on your system. And then next step is to source a specific init script from this repository. And then you can start using this. In this example here, you can, for example, check which versions of Gromex you have, then load the version, and then check what executable you have, which version, and so on. And then the next step, if you would like to run a job in Slurm, for example, you could do this in an interactive job. You could then run it, start a job, source again the init script, load the module, get some praise data sets for benchmark, and then run the job or run Gromex. Okay, and that's what I like to show you now, if it works. Can you see the other screen? Okay, that's not so good. Okay, so here I'm on a system in Norway, on an HPC system. It's a bit older. Let's see if we can see something. Okay, you don't see anything here, but you will see shortly what system this is, what architecture it has. So first is that you check if the repository is available. Okay, so here you see that's available, and then you would source the init script. Oops. Okay, so this was quite fast, probably because I just did this before and the cache was already filled. If you do this the first time, then it can take a little bit more time. So what you see here is it is using the Haskell build for the system. Actually, I think the system is Broadwell, but yeah. So this is we have no build for Broadwell, so this is the best fit here. And then, as I said, what you can do now is just to say something like module Gromex. And what you see here is 2 sections, basically, what the modules we have from EaSI. And here you would also see what is locally available. Yeah, and if I then just load Gromex from EaSI, and okay, and now I can see what I have here, and you see it's coming from the EaSI software spec. Okay, the version, I don't know if that's so interesting. Okay. So now, so I'm already here inside this job, so I don't have to start the job. I'm on a compute node. Just want to show that you can actually do something. So I just copy the, just download the trace benchmark. Okay, so it's actually there, and then try to run this. Let's see if it works. Case. And it seems it runs. And I haven't installed Chromix on the system. Of course, there were some other versions of Chromix. I could also use them, but if that was not the case, that is not installed, I could just use it. Yeah. Okay, let's go to the next scenario. Okay, scenario 2 is EASSI is not available yet on your system. Yeah, you could again check with this command ls, see if the directory for the repository is there. And if it's not there, then in this example, I will show you how you can use Singularity to use it. You need a relatively recent version of Singularity, which supports fuse mount, but then it should work. And you need to do a bit more to start a container. So you need to create some temporary directories. Yeah, there's one thing which was on the system I hope I can use is that if the temporary directory, the /temp is too small, then you can specify a separate directory, and yeah, then it should also work. So let me see, and here is a number of environment variables you can set such that you can start before you can start a container. You have to bind some directories. So CernWFS stores some data in some /var directories that you have to provide, and then yeah, that's just for the home directory. You provide something in the temp directory also, and then so this here EasyBuild is telling that the fuse mounter comes from the container. It uses the CernWFS fuse mounter, and where the repository is and under which directory it should be mounted. And if you have set this all, defined this all, then you can just start to launch the container. You can launch a shell, and we have prepared a container for this. And that's really just a very simple, basic container, not containing much, only the CernWFS client, basically. Okay, let me see if there's more. Okay, yes, there's more, of course. And then inside the container, you start very similar to the other example. You source the init script, and then you can start working. Okay, I think I will show you this, but before, yeah, there's also some documentation linked at the bottom. And I think yesterday there was a talk about also CernWFS. So there's some alternative. You can also use a command CFS exec on some recent OS. Yeah, there's some link to CernWFS GitHub repository. Okay, so let's see. I can get the demo running. Okay, so here I'm on another system. It's an AMD home system, but here we have, I hope, I'm here also on a compute node, and here I hope I don't have CernWFS installed, and also not the, yes, okay, I don't have this here, so then I can try using container. So what I have here is okay, so 3.7. It looks good. And then the next thing I do is I create a temporary directory. But okay, so first thing what I mentioned is sometimes can be that temp is a bit small. So for example, here it is only 500 megabytes, so that could be a bit small. Yeah. So in that case, you can just, I think it's like this. And here, then you have to create some directories in there. Okay. And now you have to set up all these environment variables. So I was a bit lazy preparing some script here I can source. And then I can launch the container. So let me see if that works. Okay. There's some warnings, but there should be no worries there. And now inside I can just check if pilot is accessible there. Okay, may take a little bit of time. So it's really doing something, hopefully. I don't know. Tested it before, but yeah. Okay, I think I can come back maybe to that a bit later and see what's going on. So those two scenarios, 1 and 2, you can do as a normal user. Yeah? So if for some reason EASSI is already available on your system, you can go with scenario 1, and if not, but you have Singularity and so, then you can use scenario 2. Now the next scenario is for system administrators that want to enable EASSI on their systems. Yeah, and here I have marked those parts where we have to work on. Yeah, in a simple scenario, let's say. Now you don't have to work on these mirrors, and you don't have to install some proxies. In a simple scenario, you can just use. You just have to install some client, CernVMFS client. Yeah, so that's the first step to install the CernVMFS client. You get them from CERN. Then you have to install some EASSI configuration package, and also do some configuration of the client. And then you have to start CernVMFS on your system, or let's say the AutoFS. Okay, then the next thing is basically then you're sort of done. Then you can continue with scenario 1. And I hope I can show you this. Let me see if I can come back. Okay, so here, okay, sorry. Now I step back to this other scenario. Yeah. So now there's some more warnings, but we see that the software is available here. And now what I do is just, again, I just source the init script. Yeah. Okay, goes a bit faster. What you see here is it uses stack built for Zen2. Yeah. Okay, I can again do, sorry. So here inside, you see that here I don't have access to the software installed on the system. Here I only have access to what is available via Easy. So I can just do this Gromex. Okay. Okay. Yeah. And then see if I have no, there's nothing. So now just to show you that it's not faked. Just download again from. Hope it works. Okay, so it has also again downloaded the benchmark data, and then I can just run Gromex inside this container. Okay, yeah, it's a little bit different parameters, but yeah, more or less the same. And should soon finish. Okay, my time is up. Good. Okay, so let's go back to the slides. So maybe one slide back. So these are the 3 steps I will show you on a fresh VM on AWS. And then hopefully we have also Easy available on that system. Okay. So here, okay, I think this maybe shows you something. Okay, so this is ARM Graviton 2 VM on AWS, and now I'm just following. So there's no, I'm just checking maybe. I don't know if that works. So CMF is not installed. Yeah. So I just copy from the slides the commands to install the CMFS client. Okay, there we are done. Okay, yes, okay, it's installed. So now the next step is to install the Easy configuration package. Yeah, so I did something wrong. Okay, copy paste error. Okay, okay, and now it just installs a small RPM from Easy. Yeah, so this just this has the basic configuration, and then I need to set up some local configuration, basically specifying a client profile and a quota limit for the cache. Something wrong. I think I missed. Yeah. Missing, I guess. That's not good. Okay, something missing. Okay, add a forward. Cool. And let me see what was the quota limit. Okay, that's maybe so I can check. Okay, yeah, I don't know what happens, but we'll see. Okay, so then I just do the setup command, and then so the next is already that I can see if the pilot is available. Okay, yes, it is, and now I could basically continue. I can just maybe do the first thing here to sort the init script. So what you see here is that it actually uses a different subdirectory of the software stack. Yeah? And I can also see what is available here. Ramex, for example. And I could also just load this. Yeah, and then say what I have. This, and then I should be able to use it. Let me see. Maybe I just try this. I think I have not tried this before, so this may fail. Just download again the benchmark data. I think I can just do something like this. Yeah, okay. Also runs here. Probably takes a little bit more time because there are only 4 threads. Okay. Then I think I should go back. So now you have seen basically how you can use it when it's already available and how you can make it available. If you do this on some of your systems, particularly let's say on a larger HPC system, there are some considerations. Yeah? Of course, the client requires access to the internet. You could do this via proxy, for example, if they don't have direct access to the internet. Maybe set the CMFS cache data under this /var/lib/cmfs directory. You can adjust this via configuration setting. Yeah, there's setting CMFS cache base, and there are many other configuration settings. You can see more with this CMFS config config command. And of course, there's a lot of documentation also by CMFS developers. Okay, so the demo you have already seen. Okay, so here's the information for larger systems. Yeah, so if you have larger systems, HPC, clouds, or let's say a larger number of desktops, laptops, then you should set up also local proxies and one of these mirror servers rather than one. That's better for availability, but also better for performance. There's very detailed documentation for this from the CMFS developers. And there's also documentation for this on the documentation for EasyBuild. Yeah, they have to check for the file system there. And also at the last EasyBuild user meeting last year, there was a tutorial. I think it was also like 4 longer sessions also about this. And it's all available on GitHub, but also on, I think you can also find the videos for this. If you have a compute node without internet connection, and for some reason you can also not have a proxy, then you can use alien cache. Yeah. We also have issue on GitHub for this, which describes the scripts how to do this. Okay. That was for scenario 3, and now the last scenario is for developers. Yeah. Actually, it's quite easy to access EasyBuild from, for example, GitHub Actions. Yeah. So what you see is here is 2 things. You basically have to mount the repository. Yeah, so let's say what I've done in the scenario 3, or maybe you can also say via the container, you specify, you use something from the CMFS developers, yeah, and then you just have to specify the repository, the config, and so that's all what you have to do to mount the CMFS pilot repository for EasyBuild, and then you can use it. And to use it, the only thing you have to do is basically you have to source this init script, and then you can start. And then so that's all that you have seen already a couple of times. Okay. So this is a screenshot from where we have run this on our. We have a repository for demos, and yeah, maybe I can just try to show you how this really looks. Can you see this? So this was just run. And so what you see is if you go here, no, doesn't work from here. No. Okay, doesn't work from here right now. But
I guess you need to be logged into GitHub or.
I think I'm logged in, but it's okay. Something else. Just go maybe there. Okay, I don't know what here. So here you see something is downloaded, something is installed, and yeah, at the end, so it's doing something. So let me see. Okay, so at the end, what you see is this, there's this CMFS config setup run. So that I have also done when I installed the client on the AWS VM. And then when you want to run a demo, for example, so this runs one of the demos inside GitHub Action. You have to source the init script, and then you can start using it. Yeah. Okay. Yeah, questions, maybe last slide here. So as I said in the beginning, EasyBuild is not ready for production yet, but it's, you can of course be used for testing and feedback. We have a website, central landing page, let's say, for the EasyBuild project. There's a lot of documentation on GitHub. There's also several GitHub repositories. there was a longer introduction talk last year to EasyBuild. We have a mailing list and Slack, and you can everyone is welcome to join. We have monthly update meetings. Also, everyone is welcome to join. And last December and this January, just last week, we had 2 hackathons, and we also have plans for more. And so in a hackathon, we typically have a couple of tasks, and we try to set aside some time every week, not every week, in the week for the hackathon, and then get some things done and work together on things. Okay, that's everything from my side. Okay, a bit longer than I thought, but was there anything missing from the?
Thank you for your talk, Thomas. I'm going to start with the questions. I'll start with a question. Every time I've seen Easy demoed, I've seen GrowMax used. So what other software is available? How can I request something else to be added, or how would I go about asking?
Yeah. Okay, so we have other software available, but the list is so long that I don't want to bore you showing all this. So if I just say, so then you see there's a lot of stuff available, and some of course are libraries and basic packages, but if so I think, okay, GrowMax is here. You also have TensorFlow. Okay, that comes of course a bit later. Let me check if something comes to mind. We have OpenFoam. We have also demos for OpenFoam. We have a large bundle for Bioconductor, RStudio server. I think something else maybe. So there's quite a lot of things installed already. Okay, so many extensions installed here. Okay. Okay, so that's so there's a lot of already installed, but the focus was not so much at the moment to make a complete installation. So there's in EasyBuild there are like 2,500 easy configs. So in theory we could have all that, yeah. But to get all that, we need to have more automation first. Otherwise, it's not manageable, because for every CPU architecture, microarchitecture we want to support, we need one software stack. Okay, so then the other question was, so there are other demos. Let me see if I can find. So I think we have a demo for GrowMax, we have one for OpenFoam, we have one for TensorFlow, and one for Bioconductor. I only use GrowMax because that's the only one that works. No, the other one works also, but yeah. And then if you want to add software, so if you need other software, so ideally in the future it should work like that, we get a pull request for this, and then some automation starts and builds the package for different architectures, for different operating, for different CPU families, runs some checks, and if all that goes well, then it can be included into the software stack. And then once it's included, it's sort of immediately available everywhere. Yeah, because it is immediately available everywhere, we also want to make sure that it works.
And just to add to that, the second Easy talk we have on Friday, we'll actually talk a bit about how we're planning to do that. So how we allow the broader community to either add software themselves, so do the work that's needed to include something in Easy, or propose additions and just see how that works. So we already have quite a lot of software in here. And actually in the next version, so we have a 2021.12 version as well. There's a bit more in there. Like for example, Wharf, where Hugo and Davide are going to talk about next. That's available in the next version. And like Thomas said, we haven't really spent a lot of time in trying to make this a big fat software stack, but spending more time, let's say, in the background, making sure that everything is properly set up, that we have tests, that we have monitoring, actively looking into GPU support and things like this. So that's where we're focusing on, because we think we know how to install software, and that's not really going to be the biggest issue in this project. So before trying to attract more attention to it, we're trying to make sure that everything is properly working as we want it to be.
I think Olga has a question. You're muted.
Yeah, I know.
Were there other questions?
Ah, now it's unmuted. It's lagging so much. If, as a site, we want to extend upon EasyBuild, not adding to EasyBuild, but building our own stack on top of EasyBuild and having users doing the same, building on top of our extension to EasyBuild, how complicated would that be at the moment?
Yeah, so there are two parts, let's say. So if you use EasyBuild on top, then it's, I would say, fairly easy. Yeah.
I know the complications here. So.
Yeah, but sometimes, for example, I run into this issue is that I just had some R things I wanted to try, and okay, I didn't want to install R, so I just said, okay, let's try Easy for this. So I just did this with the R and Easy, provided by Easy, and then I ran into some linker issues. And in the last hackathon, or the last two actually, we had a task on this building software on top of Easy, and one subtask was using EasyBuild that worked relatively easy, and then the other one was doing this sort of manually. Yeah, and there I think we have also made good progress. I don't fully know what the status is, but that's something we are working on. So this should then solve my problem with R, and maybe probably also other problems. And so then there are two things one could also do then actually is one, you could install this locally in your directory or project directory on a shared file system. Or what we also think might be an idea is to have some kind of local software stack provided also via CernVMFS. Yeah, so if you have multiple clients that want to do this, and you don't want to install this on every client, then you could also benefit basically from the same technology developed and easy for the common stack. You could also do for add-on stack.
Yeah. The quirk here is that we want to use hierarchical module naming system, and we want HMNS coming from Easy, so we can add on top of that for us and our users to be able to add either onto the Easy directly or onto our extension stack.
Yeah, that makes things indeed a bit more complex. But so,
yeah.
But one thing we're also, one of the goals in Easy as well is we'll install the software. We'll include modules with that. Right now we're just using the standard EasyBuild naming scheme. We'll probably also give you a hierarchical module naming scheme for the same installation, so just different module files, exact same software. And we'll also make sure there's a script or a very well documented way of generating your own module view on what's provided in Easy. For example, if you say, I see TensorFlow is in there, but I don't want my users to use TensorFlow, you could just kick out those modules, and unless the users really know what's going on, they couldn't really use Easy straight from, they couldn't really use TensorFlow straight from Easy. So there's going to be a bit of work needed there on the EasyBuild side, like fixing all those module only issues, things like this. But that's something we actively want to look into in Easy as well. And that I know that's not the only problem. So if you break up your hierarchy in different levels, let's say, things get very messy and very complex. but it's probably possible to do this.
Yeah,
so it's not really different from having a local software stack and /apps and then allowing users to install on top of that. There's really no difference.
I sort of know how to make this work, but I was wondering how much you have been thinking about that, and how comparing to Compute Canada's way of doing that, basically the same thing.
Yeah, pretty much the same thing. I mean, it's just that we actively know, or we're very aware that people want to have different views, let's say, on the installations, and that's something we're going to make as easy as we can. Well documented, provide scripts and provide examples or God knows what to make it as easy as possible. So if you want to have a filtered view or a different view or a hierarchy or everything lowercase or whatever, you'll be able to.
Yeah.
And as easy as possible. And also something else in relation to adding software into EasyBuild, and that's maybe interesting to mention as well. There's a couple of caveats there or small complications. So first of all, you have to make sure that you're sitting on top of this compatibility layer and not using stuff from the host OS, like not anything unless you really want to. And that can be tricky for some installations. So a lot of these issues are already figured out, like for CMake, we know how to tell CMake how to behave and only look in that place and not other places. But as we add more software, there's probably going to be small issues popping up left and right that we'll have to fix. And we'll do that in EasyBuild itself. So the idea is to everything that we can push back into EasyBuild, we will. And there's over the last 2 years, several features have been implemented in EasyBuild already, which are mostly useful in the easy context. Another one is RPod linking, for example, where we don't always do things correctly. And that's also something we figured out in the hackathon, that we want to actually include the RPod wrappers that EasyBuild uses into the compiler installation. So if people do manual compilations with a compiler in Easy, that's actually doing RPod behind the scenes and they don't know, but things just work. They get working binaries and they don't run into any weird linker trouble. So it's not as trivial as saying, oh, it's supported in EasyBuild, so it will just work in Easy. In some cases, there will be a bit more work, but most of the problems that we could run into, I think we already know and hopefully also know how to fix once they pop up. But yeah, having complex stuff like OpenFOAM and TensorFlow already there, yeah, helps a lot. I mean, that at least shows us there's no huge problems that we won't be able to work around. There's another good question, I think, in Slack by Carlos. So I'll raise this to you, Thomas. I think you know the answer. So are there any plans for the long-term supported Easy? So where we don't upgrade prefix, so the compatibility layer, too often, so people can rely on it and start building stuff on top?
Or rather, no, you can't hear me yet.
Yeah, so at the moment, we rather frequently update this because we just, it's not for production, yeah. But we know that in the future, when we have it in production, we need more stability there. It can happen that you also need to upgrade or update the compatibility there, for example, for security fixes. But otherwise, we don't really need to update the compatibility layer. Yeah. So we would rather think of having stacks for much longer than what we have to now. I think we started I think maybe not last year, but the year before, we started with monthly updates, then maybe every 3 months, and now it's every 6 months. So I think that maybe if it's like 1 or 2 years, then it's ready for production.
And it's also because we're hitting problems in different layers of the project. So the compatibility layer, I think now we have under pretty good control. So Gen2 prefix is very, let's say it's a rolling release. So you have to really take care that you're actually not picking up the very latest glibc, because then your CUDA is not compatible and things like this. So you have to keep things under control. And I think we have that well worked out now, how we can do that. So if we want to or need to reinstall the compat layer, we can. And we know we'll be able to control it, what goes in there. That's a very important thing. That's probably mostly fixed by now. So yeah, how exactly we'll do long time supported versions is not clear. I think another reason that we're not in production yet is because we don't have dedicated manpower. So this is people doing this on the side because it's fun to do and try to, yeah, it's a big challenge to get this working correctly and working correctly everywhere. So it's just fun to work on. But without really dedicated manpower, we cannot claim this is production ready. If there's nobody, you can send an email if it's utterly broken and your HPC is without any software updates or new versions of installations coming in. Yeah, you don't really want that. So you want to have at least some kind of support level there that it's working.
Have to wrap up there and say thank you to Thomas and to Kenneth for the questions. To give us so we can just pause and have a quick break before the next talk, which will be in about 3 or 4 minutes.
Okay, yeah.
Thank you, Thomas.